So the first thing is, if you draw in your diagonal and label it 16, okay, probably what you would be looking at identifying is, since you're dealing with a square, what kind of a triangle is formed when you draw in that diagonal?
45.
So it's an isosceles, right, or 45, 45, 90 triangle. So the pattern for this special triangle is x, x, x root 2. And so if you know that 16 is the hypotenuse, it's equivalent to x root 2. What does anybody recall what the shortcut is for finding what the length of each side? Okay. Good. 16 divide by 2 multiply by root 2. And so that gives you 8 root 2 for the length of each side. And so now you can just use this area formula. The area is equal to the length of each side squared, or 8 root 2 times 8 root 2, just the base times the height. So if you're multiplying this, you square the 8, you get 64, square the root 2, you get 2. You get the same thing if you multiplied out base times height. So 8 times 8 is 64, root 2 times root 2 is 2. And you wind up with 128. The units are centimeters. It's a two-dimensional measurement, so square. And so this is one way to approach this. And now, some of you are more visual in the way that you approach problems, and there's another way that you could look at this in kind of a more visual sense. And that is, and again, all of these areas can be found by using the properties that we talked about in 6.3. So if we were to draw both diagonals, the fact that a square is a rhombus means that these diagonals are going to intersect at what? At 90 degrees. The fact that this square is a parallelogram tells us these diagonals are going to do what to one another? Bisect each other. The fact that it's a rectangle tells us these diagonals are both what? Equal. So what that means is where these diagonals cut off, each of these segments is going to be half of 16, right? Or 8. So if you were somebody who prefers to solve this more visually, if you cut this into these 4 triangles, let's say we took this triangle right here and we moved it to this spot. So we took this whole triangle and moved it. So this is an 8 by 8 square now. So together these two triangles add up to an area, or combine for an area of what? 64. Now what if we took this triangle and we moved it right down here? Each of these, or the combined area of these two triangles, would add up to. So what would be our overall area for this? 128. So you can think of it that way. If you, for some reason, you forget how to manipulate the 45, 45, 90 triangle, you can still work through and solve this a little more visually.